G'day guys, today I'm going to do probably one of many derivations of the cosine rule. The cosine rule is good for finding sides or angles on non-right angled triangles when we are given either three sides and we're looking for an angle, or we're given two sides and an angle and we're looking for another side on the triangle. So let's have a look at this particular triangle here, ABC. Now we've got a line that's perpendicular to AC that we've drawn, BD, and we're labeling the length of that H. We've got where the D connects AC, that's going to be length X, and the full length AC is obviously length B. So basically what we're going to do is we're going to derive the cosine rule, which is good for finding the lengths of opposite sides in terms of their angle. So to start with, what I'm going to do is I'm going to start with triangle ABD. So let's start with ABD. So we've got from triangle ABD, we can see that, let's just put a colon there, C squared is equal to X squared plus H squared. Now what I want to do here is I'm trying to get this X squared as our term by itself, so we can just rearrange this, and we can also say and X squared is equal to C squared take H squared. So I've just moved the height across to the side and subtracted it. Now what we can also do is I can have a look at the other triangle that we have, CBD. So from triangle CBD, what we have is we can say basically exactly the same thing. We can say that A squared is equal to H squared plus, now this side here is going to be B take C. B take C, B take X. Great. So I'm going to take B take X, and that's all going to be squared. Cool. So from here, I can say that, let's give ourselves a bit more room. A squared is going to be equal to H squared plus, we're going to have, this is going to be a binomial expansion, so B take X, B take X. Now I'm going to expand these brackets. Now I apologize if I'm going through this a little bit tediously, but I do think it's important that you understand exactly where I'm going. I got very frustrated with my lecturers at university when they would just make these huge jumps, and I'd spend ages at home trying to figure out where they went with their maths. So I kind of want to just go through it step by step. So we're going to multiply this out. So we've got A squared equals H squared plus, we've got B squared minus 2bx minus x squared, plus x squared. And now what we can do is that we've got this, we can then substitute, we've got x squared here, so we can substitute this function in for x squared in here. So from there, we can go, well, A squared is equal to H squared plus B squared minus 2bx plus, and rather than writing x squared, I'm going to write C squared minus H squared. Cool. So now what's going to happen is now my h's, I've got h squared minus h squared, they will cancel, which is awfully nice. So what I'm going to do is I'm going to group my squared terms together. So I'm going to go a squared is equal to b squared plus c squared minus 2bx. Now, what we can do here, we can go back to triangle ABD. So again, we can say from triangle ABD, we can say that the cosine of the big angle A, this angle here, is equal to the adjacent x over the hypotenuse h. So what we can do then is we can then say, sorry, the hypotenuse is not h, the hypotenuse is c. So what we can then do is we can then go, well, I can figure out what x equals by moving the c across, and I've got x equals c times the cosine of a. And then, like we did before, I can bang this in for x here, and I have a squared equals b squared plus c squared minus 2bc times the cosine of a, which, my friends, is the cosine rule. So basically what we've got here is, in our proof, we got our non-right angle triangle and we put a perpendicular bisector to one of the sides, called it h, and we're able to break the bottom into x and b take x. Now what we did is, using Pythagoras, we got each of the sides, c and a, in terms of x. We substituted one into the other, and finally, using the first triangle, right angle triangle that we have the angle for, we found the cosine in terms of the adjacent and the hypotenuse, and we substituted it back into our formula, which contained both Pythagorean identities. And then once we've done that, we then just multiplied it all out and we came up with our cosine rule. So that, guys, is a brief description of how you go about deriving the cosine rule. It's not too complicated. You might want to practice it a few times, and just so you can get the method right, but apart from that, it's not too tricky. So have a few goes, guys. If you have any problems with it, ask me a question in the comments section below, but until then, give the video a like, subscribe to my channel. I put out new videos all the time, but until then, enjoy your maths, please.